Welcome everybody. This is Prerna and I work as an application developer here in ThoughtWorks. So let's get started. Okay, so let's connect with GraphQL. So let's get started with the introductory part. Herein we will dive into the basics. So what is GraphQL? So GraphQL is a query language for APIs which provides complete and understandable description of data in your API. And also it gives the client the power to ask for exactly what they need. So before we actually dive into this definition, let's just for some time, let's just consider how the current traditional APIs, they are into existence. The traditional APIs or the APIs which are not GraphQL, which are in production, and how is their implementation. So for instance, let's talk about YouTube API, all right? So if I, as a client, I'm interested in some of the data from the YouTube API, so what essentially happens is that there would be an endpoint which would be served by the server, and there would be some data that would be on the responsibility side of the server, that it needs to send the data back to client, right? So there would be an exact format or structure of data that the server would be sending to the client, and server has the complete power over the data. All right. So this is currently how things are for APIs, like for REST API. So since this is currently there in production and everywhere, right? So how is GraphQL different from what we have just talked about? Just like we read here that the GraphQL gives the client the power to ask for exactly what they need. All right. So this essentially means that GraphQL API, they would be, so the client in the GraphQL implementation would be asking the GraphQL API for exactly the data that it requires. So we'll definitely get more into this in the upcoming slides. All right, moving forward. So let's talk about the features of GraphQL. So GraphQL is a new API standard, which is developed and open sourced by Facebook. And currently, it is being maintained by a large community of developers, individuals, organizations, corporations throughout the world, right? So GraphQL, it enables declarative data fetching. So what this essentially means is the exactly what thing that we talked about in the previous slide. That is, it gives the client the power to ask for the data that it is interested in. All right. So GraphQL server exposes a single endpoint and responds to the queries. So instead of having multiple endpoints, that is how the implementations with the other APIs like REST and everything is, that is how the implementations are. Instead of that, GraphQL just exposes a single endpoint and precisely responds with the data that the client has asked for. All right. So let's just see how GraphQL is a query language for APIs. So let's just consider a classic client server architecture. All right. So this is a client. Here is my client. So I am interested in some remote data, which is present in some database, which is accessible over the internet, right? So I would definitely need a server in this case, which would be serving my request from the client. All right. And I would be sending an HTTP request to the server, and the server would be responding with some data. All right. So this is how a typical client-server architecture is, right? So where does GraphQL in this architecture fits in? Okay. So we can say that GraphQL is a layer over the server. And also we can say that it is a way to get data from your API into your application. So I can simply say that wherever there is a client which needs to interact with your API, we can use GraphQL as a technology there. All right. And this can be considered a good alternate to REST. Okay. So let's talk about GraphQL, a specification. So GraphQL is a specification and it's not an implementation. What this essentially means is that a number of technologists, they just came together to develop a document which describes the rules and guidelines for the client server communication. And these guidelines, for instance, may have the information like how the request should be and what should be the response format, which also means that each of the implementations of GraphQL need to abide by these rules, by these guidelines. So we can say that GraphQL is a specification for client-server communication. And also to use a GraphQL, we need to use one of the implementations of GraphQL. And I, as a developer, this is a big plus point for me. Why? Because I might not have faith in one of the implementations of GraphQL, which is probably developed by XYZ company, right? But I need not worry about it because I have multitudes of other implementations of GraphQL, and I can just weigh the pros and cons before actually opting for one of those implementations. All right. Now, since we are talking about the implementations, let's just look more into it. Okay. So GraphQL basically has two components. One would be the client component, and the other would be the server component. So if I, as a developer, I am interested in consuming the GraphQL APIs, right? Consuming the GraphQL API, then I should only be bothered about the client implementation of GraphQL. That is, I need to be only concerned with the client libraries. But however, if I am interested in developing a full stack application, that contains the front end part as well as I want my backend to have the GraphQL APIs, right? So I would need to be involved with both of these components, the server component implementations to develop my GraphQL API, as well as the corresponding client component implementation to consume those APIs. Voila, we definitely have the implementations in multitudes of languages in GraphQL. So yeah, like it says that this can be used with many programming languages and frameworks. Cool. So moving forward, let's talk about the fundamental language constructs of GraphQL, which are the core concepts as well, right? So broadly, herein, we'll be talking about two of the main core concepts. So one would be the query and other would be the mutation. Okay. So let's here see how we can use a query to fetch the data from a GraphQL API. But before going into that, let's for once again consider our client server architecture. Herein we have the implementation of a RESTful API, which has a number of endpoints. Like there's the first endpoint, which gives us the details of a user for a corresponding user ID. And there is the other endpoint, which gives us the address details of the user with that user ID. All right. So in REST world, we definitely have multiple endpoints. And why is that necessary? Because like I've already mentioned before that in REST world, the entire power lies in the hands of the server of what data format it needs to send for a particular endpoint. And client has no say in it, right? And the data format or the data structure is very much fixed to a particular endpoint, isn't it? Now moving forward to GraphQL. But this is not the case. This is now how it is in GraphQL. In GraphQL, there's just one endpoint. All right, and why that is possible? Because in GraphQL, there's no fixed format of data that the server needs to respond with. So which essentially means that client needs to send more data to express its need, and that it does through query. Okay. So let's look at the query. So I have a sample query in place here, which fetches the details of the user from some database. Okay, so my client here would be sending this query to the GraphQL API and would be expecting a response. All right. So here the query, we have a root field, which is all users, and everything that follows the root field is called as payload. So the name here is the payload. Okay, so once the client sends this query, the query is executed by the GraphQL server. It sends in response the list of users with just one field in it, that is the name. All right, so here we can see that we have a number of user objects in response, and we only have a field called name. Whereas in real time environment, a user can have many other details as well, isn't it? Like it can have email, it can have address, but here we just got name. Why was this possible? Because this is what we had told in the query, in the payload, that we are only expecting name in response. Okay, so moving forward, if I, as a client, I'm interested in information more than name, if say I'm interested in age as well of all the users, so all I need to do is just add age in the query, in the payload, and voila, I would be getting age along with name for all the users. Isn't this great? So moving forward, we'll just see one more instance here wherein for all the fields in the query, I can provide an optional argument. So herein, for the root field, all users, I have provided, as a client, I've in my query have provided an optional argument, which is called as last, which has the value of 2. So what this would essentially do is that it would be, so when the GraphQL server would execute this query, it would be only sending the last 2 users which are present in the database. Okay, so moving forward, we can see that other than the primary fields like name, age, email, we can also fetch some of the complicated objects using just this query. And also within that object, we can exactly specify for what field I as a client am interested in. Okay, so here in my query, I've also mentioned address, which contains just a single field called city. So my response to this query would be all the users which have the name, which have the details, which are name, age, and as we can see here, I just got the address detail, which has city in it. Okay. So moving forward, we'll talk about mutations. So like in the REST world, we all know that there are some HTTP methods like post, put, patch, delete, isn't it? Which allows us to manipulate the data on the server side. So similarly, in GraphQL world, we have this concept of mutations, which allows us to manipulate the data. So this mutations, it, um, it can be broadly categorized into 3 categories. So one would be to create a new data. The other one would be to update the existing data. And the third one would be to delete the existing data. All right. So let's just see a sample mutation here. So mutation, very much similar to what we saw in query, it with the only difference that it is preceded with the word mutation. And herein we can see at the root field, we have create user, wherein I can pass some arguments as data. So I'm passing name and age in the data. And also in response, I'm expecting uh, that once this mutation is executed, the client is expecting that name and age should come as a response. All right. So herein we can see that once this mutation got executed, the response we have name and age, which is Bob, and age is 20. Now you might consider this to be a very trivial example, isn't it? Like the client is already sending some data and it is indeed expecting just the same data. So let's just do a little tweak to our user type. Let's just add ID to it. All right. And when I create my mutation, I'll create a mutation with the data that I'd be sending to the server. And in return, I'd be expecting the ID, which ID of the entity user, which got created by the GraphQL server. All right. So herein I received the response with just ID. Cool. So this was pretty much it all about the queries and mutations. So moving forward, we'll see how the queries, mutations, and types, they're all engrossed into one single schema. And this would be taken forward by Shagun. And so over to you, Shagun.
Thank you so much, Prerna. Hello everyone. I'm Shagun Kapoor and I'm working as an application developer at ThoughtWorks. Yeah. We have learned in the previous session about queries and mutations, but how exactly do we specify them? This is where the schemas and types comes into picture. In yeah, in a normal GraphQL client server setup, whenever a client connects to a server, the server sends back a specification, which is our schema, which tells how the client's request should look like and how the server's response will look like. The client then stores the schema somewhere, like in a cache or somewhere, and checks or validates every request even before sending it to the server. Thus, this enables the server to focus more about the business logic instead of validating the request. So, what exactly is a schema? Schema is something that defines the capabilities of the API, like how a client can fetch or update the data, and which all queries and mutations are available for the client to execute. It is also used to define the types of data that it can include. For example, here we have a schema which has query and mutation, where the query type consists of users and address, and the mutation type is used for creating the users. Schema also gives the exact description of the data that we can ask for, like what fields can we select, what are the kind of objects that the server might return, and what fields are available on those sub-objects. GraphQL query language is basically about selecting fields on an object. For example, we have, considering the user's example, where we start with a root object, which has a user's field, and it has its subfields, which are the ID, name, and email. Whenever we execute this given query, we observe that the shape of the GraphQL query closely matches the result. Therefore, we can predict what the query will return even without knowing that much about the server. Now let's move on to types. GraphQL has its own type system that is used to define the schema of an API. Every GraphQL service defines a set of types which outlines what is the set of possible data that can be queried on the service. There are three kind of types available, which are the object type, scalar type, and the enumeration type. Now let's dive in a little deeper to learn more about these types. So the first one is the object type. It represents a kind of object that has some fields and that can be fetched from the service. For example, considering the same user's example, here user is an object type which has its subfields like ID, name, and age. Here you might observe that age field is represented kind of like a function. However, in GraphQL, this is exactly how an argument is represented. So here, each field has one of the argument, which is unit, and in GraphQL, every field and its nested object can get its own set of arguments, provided that all arguments are passed specifically by name. Now let's move on to the next type, which is the scalar type. Scalar types, it represents the leaf of the query, and these fields do not have any subfields. For example, we have five kind of scalars, which are int, float, string, boolean, and id. In the example given below, we can see that the id field is of type id, name field is of type string, and the age field is of type int. Now let's move on to the last enumeration type, which is the enumeration type. It is a special kind of scalar that is restricted to a finite set of values. For example, here we have an enum type country, which has the possible values of IND, US, and AUS. It validates that any argument of country type will always have one of these allowed types. Apart from this, we also have some type modifiers in GraphQL. These includes the non-null and list modifiers. The non-null modifier is represented by an exclamation mark, and it doesn't allow the server to send a null value. For example, we have a name field which is of type string, and it is represented by an exclamation mark following it, which says that the name field cannot be null. Similarly, we have a list modifier which is represented by square brackets, and it returns a sequence of types. For example, here we have phone number, which will return an array of phone numbers. Okay. So since schema already describes like what all fields and arguments and result types are there, but the only thing left is a collection of functions that are called to actually execute these fields. And these functions are known as resolvers. So resolver is a function that is called to actually execute the fields described in the schema. Each field on each type is backed by a resolver function. That is, whenever a field is executed, its corresponding resolver is called. For example, whenever the user field is executed, the user resolver will be called. In case of scalar values, the execution completes then and there. For example, here we have name and email, as we've seen earlier as well. These are string types, so the execution will complete there here itself. And in case of address, which is an object type, the query will contain another selection of fields which apply to this given object. Resolvers are per field functions that are given a couple of arguments. Considering the resolver function for the users, it has four kind of arguments, which are obj, args, context, and info. We can think of every GraphQL query as a tree of function calls, such that each field on each field is a function of the previous type and returns the next type. For example, here we have, as I have mentioned earlier as well, we have four parameters, and then we also have an argument ID, which is provided to the users. So here, obj contains the result returned from the resolver on the parent field, which is, for example, here, if we have an address object, its resolver function would have obj as users, as user is the parent object to address. The next args are the arguments that are passed into the field in the GraphQL query, as we've seen arguments earlier as well. So here we have ID is the argument that is passed to user. The third parameter is the context, which is provided to every resolver, and it holds important contextual information like the current logged in user or the access to the database. And the last parameter is the info, which holds the execution state or field specific information that is relevant to the current query. Till now, we have learned a lot about the features and core concepts of GraphQL. Now let's see how GraphQL is actually better than the RESTful APIs. So considering this client server setup, the REST API exposes multiple endpoints or paths to different HTTP methods like get, post, put, patch, and delete. It is the server that defines which all paths are open to the client for fetching or updating the resources. For example, if in case we want to fetch the users, we would use the first endpoint, which is the /users endpoint. It will fetch the users and send it back to the client. If in case we want to fetch a specific user corresponding to a given ID, we can hit the second endpoint, which is /users/user ID. And if in case we want to get an address corresponding to a given user, we can use the third endpoint, which is /users/user ID/address. And in a similar way, if we want to fetch a given address, we can use the fourth endpoint. However, in case of GraphQL, there is only a single endpoint, which is the /GraphQL endpoint, and we can access full capabilities of our data using this single endpoint. This request body contains a query expression, which allows us to be specific in what we would like to get back. For example, we have a query for user, where the user consists of the fields user ID, name, and email. And we have another query which has user, name, email, and address as well. So in case of GraphQL, we can simply tell what we want, and instead of figuring out which endpoint to call, as in case of REST. Now let's see the tabular version of the key differences between REST and GraphQL. So REST is URL driven. That is, whenever a request is made to the server, it has the HTTP verb, which may be post, get, put, patch, etc. It has a path or the endpoint to which the request is made, and then it has a body, which is in the JSON format, and it is usually and it is optional. Like in case of guest, you can omit this request, you can omit this body. Whereas in case of GraphQL is a query language. Here we have a HTTP verb here as well. We have a path as well, which is usually slash GraphQL in most of the cases. And then in the body, we have a query expression, which tells what query do you want to do on the server. The next, REST is a complex query and it is incredibly hard to pull off. And we need to make multiple requests to the users in order to fetch multiple resources. Whereas GraphQL is a simple query and a single query can retrieve multiple resources. GraphQL also allows the clients to fetch a lot of related data in a single request instead of making several round trips. In REST, there is always over and under fetching of information, and the REST always gets either extra or less information from the server. Whereas in case of GraphQL, the queries are very specific and returns exactly what we need. And as we've seen earlier as well, REST has multiple endpoints and GraphQL has a single endpoint. So that's it from my end. I hope you guys enjoyed the session and understood each and everything about the core concepts of GraphQL. If you have any questions, please feel free to add them in the Q&A section, or feel free to reach out to us offline as well. So now I would like to hand it over to Sakshi and Abhishek, who will explain how to approach GraphQL and how and what are the different ways to implement it.